We've spent some time looking at probability and using combinations and permutations in probability, and we're going to detour a little bit on statistics. So statistics is the collection, analysis, and description of data. And for statistics, we are only going to touch upon a couple of the basics, some vocabulary, some formulas, so that we're equipped with that vocabulary and able to see the difference between probability, mean, variance, and standard deviation compared to the mean, variance, and standard deviation in a probability distribution, which I'll address in another video. So, measures of central tendency are mean, median, and mode, and you've seen that before. So, a little bit of notation when we're talking about the mean of a population. Notice this symbol that we use for it. It looks like a U with an extra stem. We call it mu. And you recognize sigma. We know what that is. So the mean is the sum of all data divided by the number of data. You already knew that. Median is the number in the middle when the data is arranged in numerical order. And the mode, of course, is the data that appears most frequently. So in example 1, we're finding the mean, median, and mode. So the mean is 14 plus 7 plus 12 plus 4 plus 13 plus 20 plus 2 plus 3 plus 5 plus 15 plus 10 plus 4, all divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's approximately 9.08. The median, the value in the middle, well, 2 is my smallest, 20 is my largest, 3 comes next, then 15 on the large side, 4, 14, 4, 13, 5, 12, and 10 and 7 are what's left, so I find the mean of those, and that's 17 divided by 2, which is 8.5. So my median is 8.5. And then my mode is which number occurs most frequently, and I believe 4 is the only one that shows up more than once. So that's it. Another way that we talk about data is with measures of spread, like range, variance, and standard deviation. And you have very likely found range before. That's just the maximum value minus the minimum value. Variance and standard deviation are these formulas, and it's kind of hard to see on your paper, but that's the symbol for standard deviation. And I hope this isn't confusing for you, but this is actually called a sigma. It's a lowercase sigma. And so sigma squared is the variance. And it's found by taking the sum of the square of the difference between each term and the mean, and taking that sum and dividing it by the number of terms. Conveniently, for statistics, your calculator will do this for you. So you probably want to take a moment and look at your calculator and find a symbol like this, like this. This will calculate average or mean, and this will calculate your standard deviation. You want to make sure that you're in the right mode when you're doing that. On this antiquated thing, I have to be in mode period, and then after every term, I just press my M+ button. We'll have some time in class so that I can help you make sure that you know what you're doing in your calculator. But in example 2, that's what I'm going to use, is the function in my calculator to do the heavy lifting for me. So the range is maximum minus minimum. My top value is 10. My smallest value is 2. So the range is 8. And in order to find my variance and my standard deviation, I have to go through and enter all this data into my calculator. So in my calculator, right now I put it back in regular mode so that you can see that there's usually a process of putting the calculator in a statistical mode. So in my calculator, I go mode period, and an SD shows up. And now I'm going to type in my data, and after every data entry, I type in this button here. So 7, 8, 9, 9, 9, 10. Now I've entered all my data, and in order to find my sigma, which is the standard deviation, I'm going to hit Shift and then that button, and there's my standard deviation. Which is 2.1, which means that my variance is that value squared, which is 4.57 approximately. And that's what I was asked for, is those 3 measures of spread. Now it's asking me to use the last column in order to find the measures of spread for a sample of the class. So my range would still be 10 minus 2, which is 8. And in the interest of showing you how to use the formula, I'm going to actually calculate this. So in order to do that, we have to calculate the mean, because remember, back here, standard deviation is just the square root of variance. And when we are finding variance, what we're doing is taking each term and subtracting the mean from it and then squaring it. Okay, so got to find the mean. So that's 9 plus 6 plus 2 plus 5 plus 10 divided by 5. So that's 6.4. So when I subtract 9 minus 6.4, and 6 minus 6.4, and 2 minus 6.4, and 5 minus 6.4, and 10 minus 6.4, I'm going to take that difference and then square it and add those values all together. Okay, so 9 minus 6.4 is 2.6. I need to square that, plus 6 minus 6.4 is negative 0.4, square that, plus 2 minus 6.4, negative 4.4, square that, plus 5 minus 6.4, negative 1.4 squared, plus, let me move this so I have some space, and then 10 minus 6.4, that's 3.6. So I'm going to square all these values, add them all together. Now, one thing to be mindful of is that I'm finding this measure of spread for a sample. This is not my entire population. And the formula for a sample is a little bit different than the formula for the population. Okay, so when we're finding the sample variance, the numerator, we're doing the exact same thing as we're doing for the population, but we're dividing it by the number of data terms minus 1. So we're not dividing by 5, we're dividing by 4. So 2.6 squared plus negative 0.4 squared plus negative 4.4 squared plus negative 1.4 squared plus 3.6 squared, and we're dividing that by 4. And that is 10.3. So that is our variance, which means that our standard deviation is the square root of that. So take the square root of that and you get 3.2 approximately. Aren't you glad you have a scientific calculator? So how do we use this data to compare information? So in example 3, we are going to calculate which group has a greater variation in metabolic rates. And the way that we're going to do that is by finding the standard deviation of them. So because of the size of these data sets, we're going to use our calculators. Okay. In your calculator, another button that you want to make sure that you notice, or another function, perhaps, because it probably doesn't have a button all to itself. I already talked about this button. You probably want to make sure you notice this button as well, because as I mentioned before, the formula for finding a population variance and a sample variance and a population standard deviation and a sample standard deviation vary just a little bit. Okay, so in this particular example, this entire group of people, both of them put together, that's my population, but this is a sample and this is a sample. So I want to make sure that when I'm typing all this data into my calculator, I'm considering it as a sample. So after all my calculating is done, or the calculator's calculating, I find that this group has a greater variation in metabolic rates